So, we take a lot of information out of it. The periodic table is a pretty amazing thing, and we might spend a bit of time later in the term just having a look at how impressive Mendeleev was in the way that he organised these elements and identified patterns in their similarities. But apart from the genius of the periodic table, we can use it for helping us identify key features about atoms and certain types of molecules, I guess. So I've labelled this diagram. This is how a periodic table looks in general, a symbol in a periodic table. So I've zoomed in on one of the boxes in a periodic table, and you'll notice there's a number on the top, a letter, or sometimes two letters, and then a number with 2 decimal places usually on the bottom. Now that might be a little bit different in each periodic table, but the top number is always, does it have decimal places ever? No, it's always an integer, and the numbers here always seem to be not quite exactly, pretty close to, particularly early in the periodic table, they're very, very close to 2 times that number. Happy with that?
Yeah.
As you get further away, you notice they don't quite keep constant with that. So uranium, for example, I think that's number 94, and its number is 238, I believe. I'll have a look and tell you. Uranium is 92, and it is 238.03. So, no, whatever, it doesn't matter, but whatever the number is, it's not 2 times, that periodic table says 238, I don't know which one's right, but it's not 2 times 92, is it? 2 times 92, 184, significantly more than that. But early on, not hydrogen, let's ignore hydrogen, helium is 4, beryllium is 6, etc., around those numbers. The A, or the number on the top, what is that called? The atomic number, and that tells us what?
Protons and electrons.
How many protons? I like to use the word electrons because I was going to go forward from there. Definitely tells us the number of protons. Can also be used to assume number of electrons. Now the reason I say it can be used to assume the number of electrons is because electrons can move in and out of atoms. Protons, for all intended purposes right now, can't. Protons are stuck where they are. Electrons, because they sit on the outer shell, can be taken, can't they? It takes a lot of energy, but in general, if you have 6 protons in an atom, how many electrons do you assume you've got? 6. If you've got a different number, what do we call that? Starts with I. Ion. It's called an ion. So if it's charged, if there is an imbalance between the number of protons and the number of electrons, we call that an ion. But for most atoms, we assume that the number of protons is the same as the number of electrons, so very good, Hannah. B, what's that? It's a symbol. More useful in chemistry than it is in physics, but it still can be help us find the atomic number and the atomic mass, for example. I'm not going to write anything about the symbol. It's just a quick way of identifying what atom we are actually talking about. And C is our? Very good. Atomic mass. And the atomic mass tells us what? How many protons and? Neutrons. Okay. Are in each atom. So if I have, for example, let's assume if I have 92, so I've got uranium, 92, and let's just assume it's 238. Can you tell me how many protons, electrons, and neutrons are in that element there? Thank you. Let's go.
9